Hello students, here your fourth lecture, Bohr theory of atoms. I think the previous YouTube lecture have gave you the information regarding different atomic models. Bohr can give absolute clear picture of atom. It was based on a partly quantum mechanical approach which is made more elaborate by Schrödinger that you will study in the next chapter of your syllabus. Here we are discussing postulates of Bohr theory of hydrogen atom, Bohr's calculation of energy and radius of electron of hydrogen atom, its spectrum, and the limitations of Bohr model. Here I am discussing the postulates of Bohr theory. The first postulate is that the electrons in an atom revolve around the nucleus only in selected circular orbits. Each orbit is associated with a definite energy, with a definite whole number of quanta of energy. The orbits therefore known as energy levels or shells. Bohr gave numbers 1, 2, 3, 4, etc. to these energy levels, and these numbers are now termed as principal quantum numbers. The various energy levels are also designated by letters K, L, M, N, etc. The next postulate is that the energy of an electron cannot change continuously. It changes abruptly as the electron jumps from one energy level to another. That is, for a change of electronic energy, the electron has to jump from one energy level to another. Next is the third postulate. The angular momentum of an electron moving round the nucleus is quantized. An electron, like any other body moving in a circular orbit, has an angular momentum given by mvr, where m is the mass, v is the velocity of electron, and r is the radius of the orbit. Bohr postulated that the angular momentum of an electron in an atom can have only definite or discrete values given by the expression angular momentum mvr equal to n into h by 2 pi, where n is any integer. That is, the angular momentum of an electron may be h by 2 pi or a simple whole number multiple of h by 2 pi, such as 2h by 2 pi, 3h by 2 pi, etc. to nh by 2 pi. This principle is known as quantization of angular momentum. Next, we are taking a hydrogen atom with nucleus at the center and electron revolving round in a radius r for deriving Bohr equation for energy of hydrogen atom. Let the charge on the nucleus be plus Ze. For hydrogen atom, Z is equal to 1, and for hydrogen-like atoms such as He plus, Li2 plus, that is the 1 electron atoms, Z can be 2, 3 respectively. The electron with charge E revolves around the nucleus in an orbit of radius r. Let v be the velocity and m be the mass of electron. According to the laws of classical mechanics, the centripetal force acting on the electron given by Ze into is E by r square, that is Ze square by r square, tend to pull the electron towards the nucleus, but the centrifugal force acting on the electron given by mv square by r tend to take away it from the orbit. Under the influence of these two opposing forces, electron keeps revolving in its orbit. When these two forces balance, Ze square by r square become equal to mv square by r. From this equation, v square can be written as Ze square by mr. From Bohr's postulate, the angular momentum mvr is an integral multiple of h by 2 pi. From that equation, v can be written as like this. And squaring the equation, we will get this type. And from both of these equations, we can write Ze square by mr equal to n square h square by 4 pi square m square r square, and can be finalized by Ze square equal to n square h square by 4 pi square mr. From that, the radius r can be written as n square h square by 4 pi square Zme square. Here I am writing it as Rn, assuming that this radius is of the nth orbit. For hydrogen atom in the ground state, Z equal to 1 and n is also 1. Hence R1 equal to, which is known as Bohr radius. In SI system, we are applying the permittivity factor, and then the radius becomes, the equation becomes like this. And by knowing the mass and energy of charge of electron, we can have the Bohr radius as 0.529 angstrom. Then we are calculating the energy of electron in hydrogen atom. The total energy of electron revolving in the nth orbit is equal to sum of kinetic energy half mv square and the potential energy minus Ze square by Rn. That is the distance between the nucleus plus Ze and the electron minus E by distance Rn. From the previous equation, we can have mv square equal to Ze square by Rn. Hence, E can be written like, energy can be written like this. That is equal to minus Ze square by 2 Rn. Substituting for the radius, we can have the energy of nth orbit, energy of electron in the nth orbit can be written like this. This is the famous Bohr equation applicable to hydrogen and hydrogen-like atoms such as He plus, Li2 plus, Be, beryllium 3 plus, etc. In SI system, we can have the energy equation like this. And for hydrogen atom in ground state, the energy can be minus 1312.19 kilojoule per mole. and in electron volt we can have the value minus 13.6 electron volt, as 1 electron volt equal to 1.602 into 10 raised to minus 19 joule. I made some mistake. It is 10 raised to minus 19 joules. The energy of electron, this is the ground state energy, and the energy of electron in excited states can be obtained by putting n equal to 2, 3, 4, etc. in the energy equation. In the next part, we will see the origin of hydrogen spectrum, and you please keep in mind the energy and radius values of electron in hydrogen atom. Thank you.